Hello, my lovely students. Good afternoon to each one of you. Hope so you are fine and taking due care of yourself. Dear students, welcome to digital classes. This is your chemistry period, and as we are doing chapter 1 matter in our surrounding, and today we will do the topic temperature and its different scale. So maybe, dear students, you are thinking like this way, from where the temperature concept came now as we were doing matter. So let me tell you some basic introduction of this chapter, whatever we have done. As in this chapter we are doing the matter is what which occupies space and have mass. So everything in our surrounding that we feel with any one sense organ, that is called matter, or physically which we can touch or which we can feel, that is called matter. So basically it is classified in two way: physical classification, chemical classification. So as chemical classification we will do later on, but physical classification, solid, liquid, gas is the main three states of matter which can be classified under physical category. So we know very well about the differentiation of solid, liquid, gas, how solid is differentiated than gas and liquid. Then we discussed about the interconversion, how we can convert solid into liquid and to gas, and gas into solid, or in the different way. Okay, so in which we discussed that these interconversion. Now my question is that what is interconversion, that you know. Okay, why solid is changed into liquid, into gas, that you know. How it is changing, that also we know. But what is the basic reason that this solid is going to be changed into liquid, into gas? So basic factor came temperature. Okay, by increasing temperature we can change solid into liquid, and again by increasing temperature liquid change can into gas. Let's think practically, let's think scientifically. Whenever we are going to change the temperature, or whenever we are going to increase the temperature, in simple word we can say, whenever we are going to going to heat, okay, anything, then it is converting solid into liquid, into gas. On the other hand side, whenever we are going to decrease the temperature, by decreasing temperature it will go reverse, like gas will convert into liquid, liquid will convert into solid. So basic fundamental of interconversion is from temperature. So basic effect is from temperature. Okay, so because of that we are talking about temperature today. So as in yesterday's video I have cleared about that the interconversion is basically when solid change into liquid, change into gas. So solid change into liquid is called melting, liquid change into gas is called evaporation. And yesterday we discussed this topic. Hope so you understood that topic. So in that evaporation we discussed factor affecting evaporation, in which one of the major factor was temperature. As more the temperature increase, more will be the evaporation. It means the temperature is directly proportional to evaporation, as hot water will evaporate most faster than cold water. Okay, by this concept, if we will take this concept in the process of evaporating, so we can see as temperature we are increasing, if we will increase temperature, so what is happening then? These particles, molecule particles are start moving fast. The kinetic energy is increasing and it start colliding with each other. The moment it will collide, it is going to vigorously evaporate, and the moment more the higher energy, it will evaporate, okay, faster. So with this concept, I'm going to start this concept that is called temperature. Okay, so dear students, let's start temperature. But before going to start, let me ask one question from you. My question is that, can matter change its state? I'm taking a little pause, you just think and just decide yourself. Okay, so yes, maybe maximum student thinking yes, matter can change its state, as we have done in interconversion. So how does this change of state occur? This is my second question. How does this change of state of matter occur? Okay, so this question answer. Second, during the change of state, what happened inside the matter and also to the particle of matter? These three questions I have asked. So hope so when you will watch this video, after that you will send me the answer. Number one, can matter change its state? Number two, how does this change of state matter occur? Number three, when during the change of state of matter is happening inside the matter, actually what is happening to the particle of matter? Okay, you have to give the these three questions answer. So generally we have already learned that space between the particle in three states of matter are different, and the interparticle space are maximum in solid. So as we are discussing here, we have already learned the spaces between the particle in three states of matter are different, and the intermolecular are minimum in solid, intermediate in liquid, and maximum in gases. Okay, and this means that the converting solid into liquid and liquid into gas, and same way its interparticle space have to be increased. In similar way, for the reverse process, the intermolecular particle will decrease, okay, with the decrease in temperature. So basically what is the main factor that can cause the interconversion? That is change in temperature and change in pressure. So by changing in temperature and changing pressure, we can convert solid into liquid into gas. So what is the effect of change of temperature? Okay, so change of state from solid to liquid. When a solid is heated, the kinetic energy of particle increases. Now I'm giving the answer of that question. What is happening exactly inside the matter when it is going to be changed? So it start expanding due to increasing vibrating movement of the particles. As a solid is further heated, if we will heat it more, the solid stage will reach when its particle have energy enough to overcome the interparticle attractive force. That time what will happen, they leave their fixed position and start moving away slowly. And at this temperature the solid starts changing into liquid, and as a heating is continue further, more and more solid change into liquid, but the temperature remain unchanged. And ultimately what is happening, the whole of the solid change into liquid. Okay, so this change of state from solid to liquid, this change of state from solid to liquid is called melting or fusion. Okay, and the temperature at which a solid change into liquid at the atmospheric pressure is called melting point of the solid. And generally you know very well, the melting point of ice is 0 degrees Celsius. At 0 degrees Celsius the ice water start melting, and if we will take it in 0 degrees Celsius, it is equal to 273.15 Kelvin. Now 0 degrees Celsius, I think you have heard so many times in your junior classes also, but you will get surprised with the using this Kelvin unit. Okay, so dear student, this unit is very new for you. So let's understood what is the meaning of Kelvin. So as the temperature is the today's topic, so first understand what is temperature. So it is the degree of, if we will take, it is the degree of intensity of hotness of a system. In simple word, it is the phenomenon to check degree of hotness and coldness. Okay, suppose nowadays that COVID-19 coronavirus is there. So it was a very simple process at first stage that the doctor is doing, that is they are checking the temperature of body. If the temperature of body is above normal, that is above 37 degree, it means that the person is somewhere can be affected by the coronavirus or can be positive. So because of that, first they are using scanner thermometer to check the temperature. So it is a unit. Temperature is basically a unit. It is not a phenomenon. It is a unit to check. It is a unit to check the degree of hotness or coldness of the body. Okay, and the general question which I asked you, can matter change its state? Yes, it can matter. It can change its state because of two effects: by increase or decrease in temperature, or by increase or decrease in pressure. Okay, so let's discuss about the temperature. As I said, temperature is a unit. Okay, जैसे you can see kilogram is the unit of mass. ठीक है, second is the unit of time. Similar way, Kelvin or degree Celsius or Fahrenheit is the unit of temperature. So basically there are three units of temperature. Number one, Celsius scale. Number two, Fahrenheit scale. Number three, Kelvin scale. So let's understand these three scale in detail. Celsius scale can be written in degree Celsius. Fahrenheit scale can be written in degree Fahrenheit. Kelvin scale will be written as K. Okay. So let's understand first Celsius scale. It is the kind of scale which we are using in thermometer. So thermometer with Celsius scale, whatever type of thermometer, whether it is laboratory thermometer, clinical thermometer, okay, these are those kind of thermometer with Celsius scale, and it is calibrated between like this degree Celsius. So if we will take the example of water, and now we know very well there are three states in water. There are three states in water: solid, liquid, and gas. So when we will tell it is solid, it is liquid, it is gas. So solid is the temperature when it will come below 0 degrees Celsius. Water is becoming ice below 0 degrees Celsius. Okay, this is freezing point of water is 0 degrees Celsius. Boiling point of water is, it will become gas when it is going above 100 degrees Celsius. So try to understand, the solid will be the state of water when it will come less than 0 degree. Below 0 degree is solid. Between 0 to 100 degree water is liquid, and above 100 degree water is becoming gas. Okay, when the same thing we will take in the Fahrenheit, the thermometer with the Fahrenheit scale are calibrated between, like Fahrenheit, it is Fahrenheit, F not C, it is Fahrenheit. So freezing point of water is 32 degree Fahrenheit. So in case of Fahrenheit, you will write 32 degree. It means that 32 degree Fahrenheit is equal to 0 degree Celsius, and 212 degree Fahrenheit is equal to 100 degree Celsius. How to convert Celsius into Fahrenheit? Sometimes this question is coming. So very general formula is there, that is degree Fahrenheit is equal to 9 upon 5. This is a general 9 upon 5. Multiply by degree Celsius plus 32. Let's understand one concept. If we are asking, if some question, one question will be asked, how many degree Fahrenheit will be 40 degrees Celsius? So you will write this formula, and in place of degree Celsius you will put this 40. So it will become F is equal to 9 upon 5 into 40 plus 32. Okay, this is the formula. So 8 5 is 40, 9 8 is 72, 72 plus 32, it will become 104 degree Fahrenheit. It means that 40 degrees Celsius is equal to 104 degree Fahrenheit. Okay, so third scale is Kelvin scale, which is very important. Kelvin scale, it is called absolute scale also. It is also called absolute scale. Again, it is also called absolute scale. And SI unit of temperature. This is the basic SI unit of temperature. Celsius and Fahrenheit, we are not taking SI unit. SI unit means standard international unit, which is using in all over the country, not in only India, in all other country also. The temperature unit is Kelvin. So freezing point of H2O is 273.16 or 15, and boiling point is 373.16. It is very simple. If we need to convert degree Celsius into Kelvin, then we have to use this formula. 0 degrees Celsius is equal to 273.16 Kelvin. It means the 0 degrees Celsius is equal to 273.16 Kelvin. So if we will want to convert, we will use formula simple, x degree Celsius is equal to x plus 273 point. It means that when we are converting the Celsius to Kelvin, we need to add the value, and when we are converting opposite Kelvin to Celsius, then we need to subtract. So let's start the numerical which can be asked in the exam related to this. So when we are asking, when question can be there, convert Celsius into Kelvin, you see very clearly Celsius is this side, Kelvin is this side, whereas in opposite Kelvin is this side, Celsius is this side. So question can ask, suppose this is the first question, how many Kelvin will be there 25 degrees Celsius? So what we will do, simple formula, 0 degrees Celsius is 273, x is 25 here, we will use 25 degrees Celsius is equal to how many Kelvin? We will use 25 plus 273.15. It will be 538 and 72 9 298.15, but don't forget to write unit Kelvin. Okay, so it means that 25 degrees Celsius is equal to 298.15 Kelvin. Very simple, dear students, don't be confused. Whenever question will there convert Celsius into Kelvin, very simple, you don't have to do anything, you just have to add the value with 273.15. This value you need to keep 273.15 Kelvin. Okay, this side you need to add, this side you need to subtract with this. Okay, now I'm giving some of the home assignment to you. Question number 2, question number 3, question number 4, question number 5 you will do at home. Pause this video, watch this question and try to solve it. Okay, just take care of the positive and negative sign in front of it. Second is, question can come, convert Kelvin into Celsius. So here we need to subtract the value given question with this value. Very simple. If question is there 500 Kelvin into degree Celsius, so what we will do, we'll take 500 Kelvin minus 273.15. it will be there 1037 and 972 and 5242 422 270 227 point. If we will take it average 00, then it will be 6 here and 85 degrees Celsius. Okay, so 500 Kelvin will be 226.85 degree Celsius. Once cross check as I have done orally. So if something wrong is there, you can cross check it. Okay, so next some of the assignment is again here. So dear students, these 8 questions you need to solve. Okay, so this is all about for today. Now with this, the chapter is also finished. Tomorrow we will do the exercise of this chapter. After that we will start our second chapter. Okay, so hope so you understood this video and you like this video. Thanks for watching this video. And in the end, I want to just appeal again, stay home, stay safe, take care of your family and yourself. Don't go out without a reason. Okay, so thank you very much. Have a nice day.